Let's continue with the scenario from the previous example. What if we wanted to find P, the probability that X is 2, the probability that exactly 2 of the couple's children have type O blood? Because the method doesn't depend on the specific setting, we use S for success and F for failure for short. Do the work stages as shown in the example. Find the probability that a specific 2 of the 5 tries, say the first and third, give successes. So this outcome is success, fail, fail. Because the tries are independent, didn't spell very well right there. The number or the multiplication rule for independent events applies. So the probability that we want is, so the probability, success, fail, fail. We have 2 successes, and 3 failures. That's what we did on the last one. Everybody knows where that comes from, right? Okay. So observe that any one arrangement of 2 S's and 3 F's has the same probability. This is true because we multiply together 0.25 twice and 0.75 3 times whenever we have 2 S's and 3 F's. The probability that X equals 2 is the probability of getting 2 S's and 3 F's in any arrangement. So here's all the possible arrangements. And yes, I'm going to write them all down. But remember, I told you there's a better way to do it, and we're going to learn that in just a minute. All right. So we have 2 S's and 3 F's. A fail, success, fail, success, fail. So we want 2 kids. We're just going to move those S's all around. And I know it sucks to write them all down. We won't do it anymore now. Okay, this is the last time you have to do that. But what it's getting at is, how easy would it be for you to write this down? You're probably going to miss something somewhere, right? Okay, so we're going to make it a little bit easier for you. So there are 10 of them, all with the same probability. The overall probability of 2 successes is therefore, there are 10 times that we could get 2 successes and 3 failures. And again, that 10, we're going to learn how to find that without having to write down all those numbers, which gives us a 0.26367 probability. So the pattern of this calculation works for any binomial probability. That is, if the probability of X equals K, that would be the probability of exactly K successes in N trials. Which is the same thing as the number of arrangements times the number of successes to the number of failures. So to use this formula, you must count the number of arrangements of K successes in N observations. This number is called the binomial coefficient. And again, we're going to learn how to get that 10 without having to write everything down. It's going to look really hard at first, but then your calculator will show you how to do it. Okay, so Don't freak out. All right, so to get the binomial coefficient, the number of ways of arranging k successes among n observations is given by the binomial coefficient. Which looks like this, and it's actually called n choose k, n choose k, which means that you'll have n factorial, it's an exclamation point, it's called factorial in math, over k factorial n minus k factorial. And I'm going to explain what factorials are, but again, your calculator will do it for you, so don't stress out. Factorials are really easy. So the formula for binomial coefficients uses the factorial notation. For any positive whole number n, it's factorial, which is n exclamation point, n factorial, is whatever number you have, you're going to count down from that number, and you're going to multiply it together until you get to the end, which would be 3, 2, 1. So if your factorial was 4 factorial, it'd be 4 times 3 times 2 times 1. That's it. If it's 10 factorial, 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay. So we define 0 factorial as 1. The larger of the two factorials in the denominator of a binomial coefficient will cancel much of the n factorial in the numerator. For example, the binomial coefficient, we need to find the probability that exactly 2 of the couple's 5 children will inherit type O blood is. So that 10, this is how you get the 10 without having to list all the F, S, F, F, S, whatever, because I'm not going to do all that, and I don't expect you to do it either. So what you're going to have is you're going to have 5 trials. We're choosing exactly 2. So again, remember this is n over k, and k is your successes. So we would have 5 factorial over, we have 2 successes, which means that we would have 3 failures. Okay, one more time. We have a total of 5 trials that goes on top. On the bottom, it's your successes factorial times your failures. So we wanted 2 to have type O, 3 will not. Okay. That means that on the top, you'll have 5 times 3, times 4, times 3, times 2, times 1. On the bottom, you'll start with 2 and go down to 1, so 2 times 1. Then you'll do your 3. 3 times 2 times 1. So what it says is most of your bottom will cancel out your top. Remember, it's the same on the bottom and the top. We can mark it out. So all that goes away because this is the exact same. We have 5 times 4 on the top left over and 2 times 1 on the bottom, which is 20 over 2, or that's where your 10 comes from. You guys see it now. This can be done in the calculator. I'm going to tell you in a minute how to do it in the calculator, so you don't even have to do factorials, but they want you to know where it comes from. Sorry, y'all. All right. So the binomial coefficient is 5 choose 2. This should say fraction. Is not related to the fraction 5 over 2. There is absolutely no correlation between the two. A helpful way to remember the meaning is to read it as 5 choose 2. Binomial coefficients have many uses, but we're interested in them only as an aid to finding binomial probabilities. If you need to compute a binomial coefficient, you're going to use your calculator, and this is how you do it. So my calculator's about to die, but I'm going to do it anyway. You're going to type in the number 5, so your top number. You're going to go to math. You're going to go over to probability. You're going to choose NCR. I'm going to hit enter. And then I'm going to put my number in, which is 2. 5 choose 2. You can remember at 5, choose is C, choose 2, so you don't use the P one. 5, choose 2. And then when I hit enter, it's going to give me 10. So you don't have to do the factorials. Everybody good? All right. The binomial coefficient of n choose k counts the number of different ways in which k successes can be arranged among n trials. The binomial probability, the probability of a success, is this count multiplied by the probability of any one specific arrangement of the k successes. Here is the result we seek. So this is the actual formula. You're going to do the number of different ways, the number of arrangements by doing n choose k times the number of successes times the number of failures. Sorry, n minus k. Probability of success. So that would be your 0.25. So 5 choose 2 was what we had a minute ago. That gave you your 10. Your probability of success was 25. How many of those do we have? 2. Then this would be your 0.75 and your 5 minus 2, which is 3 failures. You're fine, because you probably would, I mean, somebody else has that same question, I'm sure. Not yelling at you, just saying. I'm just kidding. All right. Did I skip? No. Okay. With our formula in hand, we can now calculate any binomial probability. We don't have to write out any of the arrangements. Each child of a particular set of parents has a probability of 0.25 of having blood type O. Suppose the parents have 5 children, so the same scenario that we just had. Find the probability that exactly 3. So for A, we're doing the probability that we have 3. So our formula says, what is our number of trials?
5.
How many successes do we want? 3. What's your probability of success?
0.25.
How many successes do we want?
3.
What's your probability of failure?
0.7.
How many failures would we have if we had 3 successes? 2. So now remember, you have to put this one in your calculator. So you have to tell me what 5 choose 3 is. So remember, we do 5, math, probability, do the C one, choose 3. What do we get? So there are 10 arrangements for that one as well. So we're going to do 10 times 0.25 to the third times 0.75 squared. And when you put that into your calculator, just regularly, you get this. What does that mean? There is what?
About a 9%.
I'm gonna go ahead and put 8.8. You can say about 9. That is perfect. About an 8.8% chance of exactly 3 kids having type O. Should the parents be surprised if more than 3 of their children have type O blood? Justify your answer. So what would that probability look like? This one is exactly 3. So what would this one look like? P equals what? All right. So if it's greater than 3, what does that mean the parents have?
Either 4 or 5.
4 or 5. What happens when we do or?
You have to subtract that.
Wait a minute.
Oh.
What do we do first?
Add.
Add. There's not going to be any overlap. They can't have 4 and 5. You know what I'm saying? So just 4. So we're doing the probability of 4 or the probability of 5. We're going to set up the equation, but then I'm going to go ahead and write the probability for you. So how would I do x equals 4? We did x equals 3 up here. How would I do x equals 4? 5, choose what?
4.
What's going to come next? Probability of success is 0.25. We want 4 successes. That means we'll have how many failures? 1. For the next one, we're going to do 5, choose 5. Successes, we would have 5. That means we would have no failures. When you put it in your calculator, 5, choose 4 is 5. 0.25 to the 4th, 0.75 to the 1. 5, choose 5 is only 1. You only have that one chance. Y'all should understand that. S. There's only one way you can get that. 0.25 to the 5th and 0.75 to the 0. And the 0.75 to the 0 is kind of more of a placeholder so you guys can see success versus failure, which gives you the probability of 0.01563. What is that probability?
It's like 1.5.
1.5, 1.6, right? So should the parents be surprised? Yeah, that's a really little probability. Wife might have some explaining to do. Is everybody good? All right. We could use the calculator. Oh, look at this. We're going to learn how to use the calculator now. So we don't have to do all that work. We could also use the calculator's binomial PDF commands to perform the calculations in the previous example. So we have PDF is going to be for equals, and CDF will be less than or equal to. We'll talk about greater than in just a second. So we're going to go into second vars. That's your distribution. We've been in there before. Oh, stop. And you don't see it on the screen, but it's there. So if you go up, you'll see PDF and CDF. On part A, we had equals to 3. So if we were looking for your x equals 3, we're going to go into binomial PDF because it's equal. What were your number of trials for x equals 3 for the babies? How many babies were we having?
Oh,
5 babies.
sorry.
What was the probability of success? 0.25. And then how many we were looking for? How many successes were we looking for? 3. And then we just paste it in. So trials, 5, P is 0.25, and X value was 3 because that's the number of successes we wanted. And you guys can see that it's the same probability. So that was for part A. So what if we have the probability that X is greater than 3? So this one's really tricky because I don't have a greater than up here. So what I have to do is the complement rule and do less than or equal to 3 minus what I don't need. Okay.
Does the equal sign matter? Or not?
It will on this one because this does not include 3. You see what I'm saying? So if it had equal to, what would you not include? Anything less than.
Oh, so you're, okay.
You see what I'm saying? Okay, so this one's greater than 3. So we're not including 3, 2, 1, or 0. If it were greater than or equal to, we would not include 2, 1, or 0. So yes, it does matter whether you have it there or not. Okay, so if we have this is the same thing in our calculator of doing 1 minus binomial CDF. CDF. So we do 1 minus, we do, second vars. We're doing CDF. What are our number of trials? 5. Probability of success? So 5. Make sure you define all these. I'm not doing it right now, but you know you need to. And then how many? What's our number? 3. That's what's in our thing right here. Okay. When we paste it in, we get that 0.0156.
So if our like original thing said x is greater than or equal to 3, would we have just put 2?
So if it's, and that's a good thing to go ahead and put in there. greater than or equal to 3. It helps, and we're about to go over that actually. It helps if you write it out. I want greater than or equal to 3. So I just want 4 and 5, so I don't want these. Does that make sense? So on the other one, I'm sorry, equal to 3, it wants that one. I was doing this one. So this one would be 1 minus x is less than or equal to 2. Okay, so just watch that, and we're about to go over that.
What, less than or equal to instead of just less than?
It doesn't matter on here on the binomial. Yeah, it has to be equal to 2 because we don't want 2 either. Okay. All right. Sorry, y'all. I know it's boring. Note that the use of the complement rule to find probability of x is greater than 3 in the technology corner. The probability that x is greater than 3 is equal to 1 minus the probability that x is less than or equal to 3. So this is the necessary because the calculator's binomial NP-K command only computes the probability of getting K or fewer successes in N trials. Students often have trouble identifying the correct third input for the binomial CDF command when a question asks them to find the probability of getting less than, more than, or at least so many successes. So we're going over the question that you just asked. Here's a helpful tip to avoid making such a mistake. Write out the possible values of the variable. Circle the ones you want to find the probability and cross out the rest. In the previous example, X can take values from 0 to 5. And we wanted to find the probability that X was greater than 3. So we can either have 0, 1, 2, 3, 4, or 5 successes. We want greater than 3, so we want the 4 and 5, but we want to cut out anything else. So cut out X is less than or equal to 3. So crossing out the values from 0 to 3 shows why the correct calculation is 1 minus the probability of X less than or equal to 3. The structure is much like the one we used when doing normal calculations. Here's a revised summary box that describes the process. So we're about to do bigger problems, okay? State the distribution. And the values of interest. Perform calculations, and then answer the question. Two more pages, I'm sorry, I know. Here's an example that shows the method at work. So a local fast food restaurant is running a draw a 3, get it free lunch promotion. After each customer orders, a touchscreen display shows the message, press here to win a free lunch. A computer program then simulates one card being drawn from a standard deck. If the card chosen is a 3, the customer's order is free. Otherwise, the customer must pay the bill. All 12 players on a school's basketball team place individual orders at the restaurant. What is the probability that exactly 2 of them win a free lunch? So here's what it's wanting. You need to define X because we're going to do the probability of X is blah, 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 blah. We need to know what X is. What is X going to be? What are we trying to find the probability of? How many win, right? So the number of players who win free lunch. What else do they give us? What is important in our formula that we're going to have to do? What are the things that we need for like our binomial CDF or PDF? Say it again. We already know it's binomial. Okay, but we got to define everything first. What is 12? N is 12. What else? We need N, K, and one more thing. Yeah. What's your probability of getting a 3 out of a deck of cards?
400.
4 out of 52. And we're going to define our probability. We want that X is exactly 2. So that's what you're talking about in the very beginning where you're going to define everything. Okay. Then you're actually going to do it. How do I do this formula? I'm going to show you the formula, but we're also going to do the calculator on both parts. Okay. So N was 12. How many are we looking for? What's our K? 2 successes. What's our probability of success? 4 out of 52. How many successes do we want? 2. What would be our probability of failure? 48 out of 52. And how many failures would we have? We had 12 total. We have 2 wins. So that means 10 losses. I don't want you to work this out. I'm going to then put it in your binomial, CDF or PDF. Which one do we use? Good. PDF because it's exactly. What's your number of trials? How many are we choosing? 12. What is your probability? Success probability is 4 out of 52. And then how many do we want? What is our X value? When we put this in our calculator or we work it out, we get 17.5% or 0.1754. So if we write it out, answer the question, what is the chance or what is the probability? There's about a 17.5% chance. Exactly 2 will win. B, if 250 customers place lunch orders on the first day of the promotion, what's the probability that fewer than 10 win a free lunch? So I'm going to change this one to Y just so we're not dealing with the same variable. What's our variable, our binomial variable?
That would be the number of customers that went in.
Good. I need my N, my P, and then my probability statement. What is my N? How many are playing? What's your probability of success? Remember, we're drawing a 3 each time. Same scenario. 4 out of 52. And then what is our probability statement? What probability are we trying to find? That Y is what?
Less than.
Good. Make sure you don't put an equal to on there because it's not going to work. So let me draw it out for you. We want less than 10. It goes all the way up to 250. So I just want this. Why did I draw this? You cannot use 10 if you use your binomial CD PDF. Y'all understand what I'm saying? So we want 9 or fewer, not using the 10. So we actually have, sorry, we're really going to be done after this. Less than or equal to 10 or less than 10 is the same thing as the probability that Y is less than or equal to 9. And then which binomial am I going to use? PDF or CDF? CDF because it's less than or equal to. What's your number of trials? How many are there going to be? 250. What's your probability of success? 4 out of 52. And then what is your X value? 9. That's where everybody messes up. So these are the ones that you have to watch. When you put that in your calculator, you get 0.00613. What are the chances that they're going to receive a free lunch? That fewer than 10 will receive a free lunch.
About 6 to 1%.
Yeah, so almost no chance of 10 or fewer than 10. Sorry, I don't want to write that. I'll mess it up and I'll miss my problem. Fewer than 10 getting free lunch. All right, so this is what I'm going to do. I'm going to close out your quiz for today. What I want you to do for your homework is you check your understanding. That's the only thing you have for homework. And tomorrow during class time, you'll work. I'm going to go over that. We will have a Zoom. I'm going to go over the check your understanding, and then you guys will get homework time. So that way I taught the whole period. I'll let you work the whole period tomorrow. Okay, fair enough. Zoomers, y'all got that?